Hi guys, welcome to my channel Physics Infinity. Another interesting problem on capacitors. Here you are. So there is a capacitor. Each plate it's a square plate consisting of square plates. The side of the plate 1 meter. So area would become 1 meter square. The distance between the plates is 8.85 millimeter. So 8.85 times 10 to the power minus 3 meter. Well, this capacitor has a cell of EMF 500 volts that is applied across the plates of the capacitor. The positive is connected to the plate X and the negative is connected to the plate Y. These plates are lowered with a constant velocity V equal to 1 millimeter per second. 1 millimeter per second in a container which has an oil of dielectric constant 11. The dielectric constant of the oil is 11. Of course, the permittivity of free space or air is 8.85 times 10 to the power minus 12 farads per meter. This is the permittivity of free space, or same as that of air. Fine. Now, as these capacitor plates are coming down in the oil, then the overall capacitance of the arrangement goes on increasing. Why? Because a part of the capacitor plates which are in the oil, that oil capacitor would have value increasing and increasing value. It will be increasing value because C is the sum total. The two capacitors are in parallel, the C of the oil and the C, the air part, the capacitor air part. Fine. As the capacitor is increasing, the PD is maintained constant. So this means automatically charge will flow more and more from the cell and accumulate more and more on the plate X. Of course, if at any instant the charge on the plate X is Q, then on the plate Y will be minus Q. Right. So what I do now is we have to work out the current. We have the current that is drawn from the cell, from the voltage source, Current is increasing. Current is of course maintained constant, and that will be dq by dt. Q is increasing with time. I am taking Q as a charge on the plate X. Let's begin. Let's come to the figure 2. I think it's explained well. So at any instant, let the length of the plates inside the oil be X, so that the oil capacitor would be epsilon naught kappa, the dielectric constant, K, the dielectric constant, okay, K, X into A, the area. So X multiplied by A is the width of the plate. Of course, A is 1 meter, that's another thing. Divided by D, the separation between the plates. Then the capacitance for the air part, epsilon naught, and the remaining length of the plate inside is X. So outside will be 1 minus X, because the total side of the plate, each side is A equal to 1 meter. So 1 minus X into A. Once again, A of course is 1 meter. A is 1 meter. I've written A here, but in the calculation we all know A is going to be 1. So divided by D. Adjust this, I get this as, I put that the value of kappa, dielectric constant, as 11. Adjust this, I put A equal to 1. I get epsilon naught 10x plus 1 by D. Interesting thing, C is a function of X. Let's talk about the instantaneous charge on the plate X. So Q equal to capacitance C, I should take big C. So C into V, well, that is epsilon naught 10x plus 1 upon d into the voltage V, and again, of course, Q is a function of x. To find the current I, it is the rate of change of the instantaneous charge with time, so it is dq by dt. Well, I use the chain rule. This can be written as dq by dx. Q is a function of x, so we can take an easy derivative of that, into dx by dt. Dx by dt is the velocity with which the plates are coming down, value given. So this becomes dq by dx into v. That becomes 10 epsilon naught vv upon d, because dq by dx, I take the derivative. Q is this, which is a function of x, and I take the derivative of q with respect to x. I put on the figures, I get a neat answer that I've done it for you. 10 epsilon naught voltage into velocity divided by d. I put the figures in this expression, all the values that are given, and I get the answer 5 nanoampere. So 5 times 10 to the power minus 9 ampere. Well, that completes the solution to this problem.
If you love the video and want me to make more useful videos for you, subscribe my channel and hit the bell icon to stay updated.